So in week 3, we are going to continue our discussion of uncertainty. In the last week, week 2, we ended with a discussion of discrete probability distributions. So this week, we are going to focus on continuous probability distributions. In other words, we will be discussing patterns of uncertainty when outcomes are continuous. And also, as part of our discussion in week 3, we will spend time on probably the most important distribution that you will encounter, and that's the normal distribution, also otherwise known as the bell curve. So let me look at your syllabus, as I always do for these weekly reviews and guides. So where are we here in week 3? So section 6.1 and 6.2, they cover the continuous distribution. And I would also stress for you that as we go through week 3, not only should you devote time to understanding the normal distribution in particular, but also get a thorough grasp of how you would use Excel to do the probability calculations involved for the normal distribution. So the normal distribution is something you will encounter not just in this course, but in many other courses, accounting, finance, marketing, and so forth, where uncertainty assessments arise, and you are likely to encounter the normal distribution. So understanding how to use Excel to do those calculations would be very helpful for you. So pay attention to that as you go through week 3. So coming back to our guide here, let me just, as I did last week, let me give you a couple of examples of settings where continuous distributions would be helpful. So the first business problem is a very practical one. Fuel is a major cost of logistics companies like UPS. Actually, they were very important for companies like the airlines, but unfortunately these days they're not flying all that much. But large logistics companies, their fuel costs are a very major component of their business costs. So they often enter into long-term fixed price contracts for fuel. So they buy fuel contracts where they from fuel suppliers where they pay a fixed price for a certain long period of time. And how should they price that contract? So obviously the price of fuel varies over time. If the price of fuel goes down a lot, then they would have overpaid. Whereas if the price of fuel is likely to go up, then they save money by having these fixed price contracts. Obviously, judging what's a good fixed price for a long-term contract depends on the pattern of uncertainty of the price of fuel. And if you think about the price of fuel, that is a continuous variable. Theoretically, it can vary from 0 to some fixed number. I don't know, let's say $80 a barrel. Okay, so anywhere between 0 to 80, the price can vary, and it's a continuous variable. So the pattern of uncertainty, how likely is it that fuel would be $80 a barrel? How likely is it that fuel will be $40 a barrel? So unless you have some idea of that pattern of uncertainty, it will not be possible for you to determine what is a good fixed price long-term contract for fuel. So that's a business setting where an understanding of continuous probability distribution will be essential. A second example is a staffing question, really. So the question being asked is, what is the likelihood that a customer calling into a medical helpline will have to wait less than 3 minutes before someone answers? So if you think of the time that a customer is on hold, that time is random and it's continuous. It can vary from 0 theoretically to infinity, or from 0 to however long before you get fed up and hang up the phone. So it's a continuous variable, and you need to have the pattern of uncertainty in order to make this kind of estimation. Obviously, the likelihood that a customer would wait less than 3 minutes depends on staffing levels at the help center. So this kind of probability calculations are done by operations people to balance costs. The more staff you have, the more expensive it is, and balance that against customers having to wait too long before help comes their way. So these are two examples of business problems where a knowledge of continuous probability distribution would be helpful in addressing them. So as I said, the normal distribution is perhaps the most important probability distribution. So let me give you an example of that. So a normal distribution, you will find out later on, is bell-shaped. So you see this bell-shaped distribution. This is the pattern of uncertainty. This is the distribution of pizza delivery times. So you can see in the middle it says 30 minutes. So most of the time your pizza is delivered in 30 minutes. So the y-axis is probability, sort of. So you can see that it's very unlikely that the pizza will take more than 45 minutes to deliver. It's also very unlikely that it will take less than 15 minutes to deliver. This is very small, this value. So if you know this pattern of, if the pattern of uncertainty is this kind of a bell shape, then one can ask the questions, what is the probability that your pizza will be delivered in less than 35 minutes? You know that many pizza shops, they give guarantees that your pizza will be delivered in 20 minutes, otherwise it's free. So knowing this kind of a distribution, the pizza company can make an estimation of how much money they're likely to pay out in terms of free pizzas. So these are business calculations that one can do, but doing these kinds of calculations requires some knowledge of continuous distribution. So that will be our focus for week 3. Our focus will be on continuous probability distributions.